गेट बंद कर देने वाला, गेट बंद कर देना. Hello, hi guys, good morning. Just let me know quickly, like we can like I can see Pratik, Vamsi, Warzone Gamer for sure. Yeah, the best part is you guys come so early. So just quickly, first of all, let me know that if everything is visible or not, everything is audible or not, anything whatsoever is not visible or audible, just let me know quickly, fatafat. Just let me know that, and we will see all the problems. Oh god, like acha, just a heads up that whosoever watches this video after the live stream end, can you please quickly like just put the timestamps of all the 4 problems with their problem names, so that I can just pin that, so that it will be helpful for the wider group, and that's super helpful. Cool. Other thing is that the problems whosoever has made this, oh god, I don't know what math freak he was, but entirely 1 2 3 entirely was if not math but math, like what the. And the 4th problem was the easiest problem out of all the problems. First, second, third, oh god, second being the hardest, third okay, like easier than the second, and then the first easier than the third. So the ranking would be 2 3 1 4. This is the ranking of today's contest problems, which I think. Just let me know your comments of what you think, that what should be the ranking of the problems, of how hard it is. But yeah, we will not only see that how to solve the problem, but also some of the other things which come to our mind, and for sure it will actually help you, because if you just look at the problem number 2, it has a constraint limit. So what if the constraint limit would not have been there, as in there was no limit thing inside, then how you could have solved it in just one line. So we'll see some follow-ups. So before that, let's quickly just write down below that how you thought of today's problems and stuff. And yeah, if we are just like we started a bit early, so no worries on that part. But for the folks who don't know, we have just opened our new Instagram page. This is this one, easy peasy DSA, easy.peasy.dsa, and also the Twitter one. So we will actually be posting stuff here. Right now I just posted a bit starting stuff, but many cool stuff will be coming here. For example, the shorts which are actually longer than 1 minute, so for sure those will be coming here. Cool. We quickly start off with the problem statement itself, going on the first problem itself, and then we'll quickly go on and we'll see everything whatsoever. So the first problem, it says that distribute the candies among children 1. Now it says that we are having 2 positive integers n and a limit, and we have to return the total number of ways to distribute n candies among 3 children such that no child get more than limit candies. Now this is a problem statement which can have multiple ways to solve. We will see of every intuitional procedure to do it. If we go on now, again we will see everything, constraints and all that stuff. So starting off with what it is asking, it is asking to distribute the candies among children. Now I have n candies with me, but I also have a limit, which means I can give one child maximum of limit, let's say L candies I can give to one child. So that's great. And yeah, for sure, if you guys like it, or if you guys like these live streams, then please hit the like button. That would be super helpful, because lately the reach has gone down. It demotivates quite a lot, but yeah, that would be super helpful if you can just like it, or just comment down below, like spread love. Super helpful. Cool. Now return the total number of ways to distribute n candies. Of course I had n candies among these 3 children. Okay, I only have 3 children, such that no child gets more than limit candies. Now forget this fact. Let's say if I would have not given the limit candies, then if I would have asked the same problem, then what could have been the best way? Again, there could have been multiple ways, but if I say you that you have n coins or n candies, you have to distribute that to 3 children. So I can just say, okay, I have 3 children as A, B and C, and I can distribute these n coins to these 3 children. So just find the number of ways, again find the number of ways in which this equation can be solved, and that's a standard permutation question. How? it just says this fact as I know that I have n coins, right? Now let's imagine let's say I have 8 coins. I have these A, B and C. Now for sure some coins will go to A. Let's say I have 3 replicas of A, I have 3 replicas of B, I have 2 replicas of C, representing, again, I'm teaching you a permutation combination. This would not help you in this problem and neither the next problem, but it will help you in the future problems. Now why I'm teaching that, I'll tell you it like later on. It should be important for you to know these facts. Now it will be super helpful in other problems of permutations and combinations. I'm just right now telling you the number of ways that you have these n coins. Now why I'm using the term coins rather than candies, because coins is a standard term when you are reading any documentation for permutation combination for solving it. I'll show that documentation also. So like while I was trying to do it, no one is good in maths permutation combination, so it's good that just try and find and search that same thing out. So main documentations opened about PNC and stuff. The best one I got was this one. I'll just paste this for you guys. It is kind of the best one I liked. So it always gives issue for me to pin this up, but no worries. If I can pin it up, right? I cannot. Oh, I can pin this now. Cool. Now it is the best documentation which I could find for PNC for all the groups, all the formulas and stuff. So if you just go down into this, then you will see that where it is gone, the same thing. Yeah, so you will see that how many solutions does this equation have in the non-negative integers, which means I have a plus b plus c and equal to 100. So that's a sum problem. Okay, a plus b plus c equal to 100. So how many number of solutions are there, which means 100 I can divide in how many number of ways in 8, m, b and c. Again, it's a non-negative integers. It just says that the answer will be 102 C2. Why is that the case? It is just that if you have these 8 coins and you have to distribute them into 3 children, so you can just imagine I have these 8 places, right? I have to distribute and just place some bars. To place bars, I also need some place. So what I will do is I place again two places just to place bars such that I can separate the groups. Okay, this I will just allot 1 to them. Now this will be the child A, this I will allot to child B, this I will allot to child C. Now to have distributed in 3 groups, I need 2 bars. For these 2 bars, I am bound to place my ones here. So answer will be n. Now number of these things, which are actually right now 3 for us, so n plus 3 minus 1. 3 minus 1 is saying me how many number of bars I can actually or places I can actually make. For 3 groups I need 2 bars or 2 places. n plus 3 minus 1 c. Out of how many? I just again need these 2 places, so it is 3 minus 1. So with this fact, by using this formula itself, which is n plus 2c2, you would have found this answer if the limit condition would not have been there. Oh fuck, sorry, I forgot again. My window changed. Sorry. So again, by this fact, what will happen is that you just have these separated. So for these 2 places, you need to place a bar at this location. So I'll just go back. So you know that you have n coins, you have to just place some bars. To place some bars, you will just know how many bars to place, I have groups as 3. To separate 3 groups, I need 2 bars. So I know I will need 2 places. So how many number of places I need? I need n plus total number of groups, which are actually 3, minus 1 number of places I need, and in those places I will just place how many number of bars? Just 2 bars, which is actually 3 minus 1. So that will be n plus 2c2. So that would have been your answer if the limit condition would not have been there. But okay, so that's the thing which I told you right now, and it will be super helpful for you. So that's the reason I showed you that. It's an entire documentation, so you will see that okay, you have these children's, and then you can place the bars here, place the bars here, place the bars here, and then get the answer, which is nothing but, as we discussed previously also, n plus r minus 1 cr, or n plus r minus 1 c n plus r minus 1 c n minus 1. So again, that is something what you can actually see and get to know with the documentation itself, but still it's actually very beneficial to actually know. Coming on back to what we have to do, we have to put a limit. Now again, when the limit comes in, so we cannot just manually put limit in a PNC, so that would not work for us. Okay, so this way is gone, we cannot use this way. But again, please make sure that you learn and write this way, because it's very important. For sure it will be asked later on. Cool. Now coming on back, that what we have to try, we can just say that what I can try ultimately is, I have these 3 childrens, and for every child I can give him some number of candies. Okay, cool. What I will do is, for this child right here, let's say I give him candy as 0, which is C0. I give him candy as 1, I give him candy as 2. Now for sure you can give how many candies? You can give n candies to him, right? Now we are looking at another way to solve it. What is the next intuitional way to solve it? We can give him n candies. Okay, cool. We can give him n candies. Great. But no, we cannot give him n candies. We can give him limit candies. So for the first child, I will try to give him 0, 1, 2 up till L candies. Cool. That is done. Now for the next child, what will happen is, okay, next child will go and say, okay, if I give you 0 candies, for sure the candies remaining for the next child will be n minus c. Let's say it is C0, C1, C2 up till CL, right? So for the next child, the candy remaining will be n minus C0. If I give first child candies as C0, next child can take n minus C0 candies. Again, it is just an option for him. Still, he can either choose to take a 0 candy, 1 candy, 2 candy up till n minus C0 candies. He can take, and then same, let's say he takes let's say mid number of candies, he will just pass in, okay, I have taken n minus c, let's say k candies. For you, the remaining candies I will just pass on to you, and you try to take something from them. Ultimately, I just have to make sure in the end that when my entire, and you saw that it's kind of a recursion, that I can take something, then I will pass on to my next number. Okay, for me, ith index, I'll take on something as in c I candies I will take, or c k candies I will take. And what is ck? K is from 0 to L. I cannot go beyond L. I will take these number of candies. Now whatsoever candies remaining, which is I took this candies, the remaining candies are n minus ck. Because if I take a ck candy, remaining candies are n minus ck. I'll ask, bro, what you do next, bro? You take n minus ck number of candies from whatsoever is remaining, and then you can just go and try for the next number. When the next number comes in, he will have to try to take either a 0 candy, 1 candy, 2 candy, 3 candy till n minus ck candy, because it is optional for him. You offered him n minus ck candy. It is optional for him. Either he can take 0 candy, 1 candy, 2 candy, or up till n minus ck candy. And again, he will do the same stuff. He will take some candy and he will ask the next child, bro, I plus 2, you, again I'm offering you, let's say x candies, you take any less than x, less than equal to x, you can take any number of candies. Ultimately, when everything is over, ultimately I have to check whatsoever I plus 2 has offered next, it should actually be 0. If it actually is 0, which means, okay, for sure I have got on my grounds, which means I have distributed every child at least some candies which are for sure less than equal to L, because I have put the condition initially itself. And also for sure that the I plus 2, which is okay, it is actually 0 index, 1 index, 2 index. So for sure after index 2, whatsoever he is offering it is actually lesser than my, it is actually 0, so no candies remaining, and I am very good to go. With this fact, you will just say, okay, this combination is perfect, and with that you can add an answer. What is the complexity of this? Simple. That firstly, you will go on, as you see, you will go on to all of these indexes. So 1 is the index, so for sure will come. 3 will for sure come, and for sure 3 children are there only, which is for sure bound, so 3 will always come. For every index I'm going on to all the n candies, or you can say all the L candies, right? Because maximum is L, so you can say, okay, for every index I'm going to L candies. Now when I go on to L candies, my recursion will internally, even if I memorize, although if I don't memorize, so it will be L raised power L. Even if I memorize, then still for every of this, let's say he took, let's say he took a CK candy, still the next person will have again options to take out of all those L candies. So it will be 3 into L square. That would actually, like, we'll see the code of DP, that will actually work. That will actually work for a smaller values of L. It will actually work. But if you go on the next case, that 1 is 6, it will not work. So let's quickly see the code for the smaller case, because it is more intuitional. That, okay, you can just try to give first person X number of candies, and then whatsoever is remaining, try to give that remaining number of candies to the next person. So what I did in this is, I just make a vector, like for sure I have to memorize this fact, so we'll go on to the memorization later on. But the main fact was, I only have 3 children, I equal to 0, I equal to 1, I equal to 2. Now as soon as base case we'll go on to later on, but you will see that for every child, which means I am at the ith child, initially starting from 0, I will try on and give him all the candies starting from candy 0 to actually candy, which is minimum of n comma limit. I'll try to give him these many number of candies. Now when this is done, what he will do is, okay, he took candy number of candies, right? Remaining candies are n minus candies. N is nothing but I passed him, okay, I'm giving you n candies as an offering, you take candy number of candies, remaining candies you pass on to the next number. So I passed on n minus candy number of candies to the next number, which is I plus 1. Limit is for sure it will remain constant, and thus I will just try, okay, if I take is, let's say, candy as 0, candy as 1, candy as 2, all the answers simply add up and simply return back. And for the memorization part, simply you know that your I and N are changing, you have to memorize it. And by this also you can see that your complexity will be I into N into this number, which is actually minimum of N comma L. So it will be I into N into L, or basically 3 into N into L. N into L, both are less than 50, for sure it will work. So with this fact, it will work. Let's come out to base case. Base case is nothing but, if I reach the end, it will actually come on that, okay, N is equal to 0, which means I have reached the end, which means all my childs are finished. Candy remaining should also be 0. If it is 0, okay, it's a good combination. If it's not a 0, it's a bad combination. If any way in the middle I get my N equal to 0, which means no candies are remaining, so for sure each child remaining, which means each child next will actually get a 0 candy. 0 candy, which means, okay, everyone after me, after this location index, will get 0 candies. It's just a one way. So this is the base case for it, and for sure it will actually work for this particular case. That will be O of N into limit into 3. Coming on to the follow-up question for this, which is actually distribute candies among children too. You will see that the number of like dislikes, because it's not a good problem to give for question number 2 at least, and also it took a lot of time and lot of effort, everything. It's not a that good problem, but yeah, for learning and stuff it can be good. Now in this, what you will see that you have to think of something else. For sure you cannot apply PNC, for sure you cannot apply DP. You have to think of something else. Now what can be that something else? We'll quickly see and have a quick chat read, then we'll go on to the more optimized solution than what we discussed as of DP, and before that we also discussed a PNC solution, which for sure would not work for this question. Now cool, let's quickly, like, meanwhile if you're watching, can you please smash that like button? That will be super helpful. Now going on, how can I, okay, screen change, thank you, Aryan, thank you so much, Namabrai. By window change, yes, for sure. Sudhanshu, who solved the worst time complexity in using the 3 for nested loops. Yeah, that is true. Same Joss Paul, 3 by 4 solve. I'm not able to. Third one, oh, like Supreet, if you're able to solve question number 2, that's super great, because I thought question number 3 was a bit easier than question number 2, because question number 3 was straightforward, saying that it's like a standard stuff of including and not including, which means if you cannot solve something by taking it, just solve something by not taking it. We'll see, we'll go on to it, but let's quickly jump on to question number 2. Now we have seen 2 ways. Now we have seen the optimized way for this. Now again, we have to think of some formulation around this fact that, again, the problem is still the same. I again have a plus b plus c, and that is actually should be equal to n, exactly equal to n. The condition is individually that a, b and c should be actually in the range from 0 to n, which means non-negative integers, and for sure in the range of n. That is the limit which is given to us. Cool. Look, limit is L. We have to see one thing. We cannot try these 3 loops for it. Okay, I cannot try the 3 combinations for it. That will be worse than the deep solution. We cannot try n square because we have already seen it. We can try something of n log n or O of n. N log n math arrangement pattern, that doesn't seem like it. O of n might work. Now when I say O of n might work, then okay, for sure O of n I have to make it work, or O of n log n, but log n factor for this pattern kind of problem doesn't make sense. So O of n, I have to make it work in O of n. To make it work in O of n algorithm, one thing for sure, I have 3 variables. I have to find what is the possible ranges of these 3. As you saw, what is the 3 loops? 3 loops is just fine. Okay, if A is this, then B is this, then C is this. What if I say I cannot go on to all 3 loops? What if I fixed one thing? If I fix one thing, other 2 will be variable, right? So what I will try to do is, I will try to say, okay, I will fix this, or let's say I will not fix this, I will make this variable, and I will find this value. In O of n, I can try for all the possibilities, right? I am saying that I will try to find for all its values whatsoever is possible. So I am just saying, okay, ultimately, now I am just telling you the how to, okay, you have this problem, you know I have solved an O of n, then you have to find, okay, how the intuition gonna be built. Again, it's very hard. If you have not seen this problem in an interview, for sure you would not be able to come up to the solution. So don't worry that, okay, it's hard, how will you gonna do it? It's impossible, like it's very hard. It needs at least like a lot of time, or maybe some hint from the interviewer. With your own mind, it will be very hard for you to actually come up with the entire intuition process for it. So in this, what we saw is that, okay, we'll just fix it. Now for that, I have to try for all the possibilities of A. All the possibilities of A is just meaning just try for all values of A, which may be in worst case 0 to n. So I'm saying, okay, I'll give you the correct value, numerical value of A. Now when you have the numerical value of A, can you just find out the possible values of B, considering that you know what could be the C? Again, I'm saying that's the part portion which is tricky. I'm saying that this is fixed. This is fixed. Now these 2 can be variable. I'm saying, let's say you would have known the range of C, or basically you would have known the possibilities of C. So can you find the possibilities of B? And with that, you know, okay, that what can be the possibilities of B. Again, A was fixed. I tried to check for C. If C can give me something, now C will say, okay, I can give you this thing, which in turn can make me sure that, okay, B can give me a range where it is not impacted by C. Now we will see that how we can actually solve it. If it didn't make sense, no worries at all. Firstly, we have to fix A, which means I have to try for all the possible values of A. Now when I say try for all possible values of A, for sure you will try for a range of values of A. In worst case, it can be 0 to n. Now let's find what is A minimum and A maximum. Now for me, A minimum is the starting range of A and the ending range of A. Now I'm just trying to find out the minimum to maximum. I have to start off my range of A, and then I will just fix it, which means I will just try for the entire range of A. But to find this A minimum, I need this thing, I need this thing. So what I will do is I will just simply say one thing, that I need to find some conditions where A is more. Cool. So what I will do, I know that okay, my A is more than 0, so that's one condition. Okay, it is it. A is more than 0. Sorry, more than 0. That's one condition for A. Okay, cool. And one condition for A for less than is A is less than equal to L. That's another condition for A. No worries. Now one thing can be that you have a plus B plus C. So what if I choose to do that this A plus B plus C, or I just have to figure out that, just remove everything out. So let's say I just do A equal to N minus B minus C, or I could have done is that like I can just write the same thing as, if it is less than equal to this 3, so I can just say that A, if it actually N minus B minus C, A is actually N minus, now B and C's value, if I just place in as the minimum values, it will be a 0 0, and the maximum values, which is for sure it can be a 0 0. So one thing is that okay, A is less than equal to L N, which means I am just trying to place in and finding the range of A. Okay, A is less than equal to N, that's one thing. Okay, A is less than equal to N, that is for sure, it's obvious for us also. And also if I place a maximum value of B here, which is L and L, so I'll just say okay, A equal to N minus 2L, and it's a maximum value, so right, it's a B's maximum value, so which means I'm just trying to put in maximum values of B. So for sure N should be more than equal to this maximum, like whatsoever B is maximum, or like B is maximum, so it just reduced quite a lot, so it should be greater than, like my A should be greater than this minimum value. So this will come out to be N minus 2L, so just say okay, it should be greater than N minus 2L. And again, this range can vary for any of you, and whatsoever it is possible. So no worries, you can also take in anything, but just put a condition while checking the final range, that if it's actually correct range or not. So for us, we just figured out that A should be greater than equal to like maximum of whatsoever is 0 comma N minus 2L, and A should also be less than equal to just minimum of N comma L, because I cannot try bigger than L value for sure, and also if it is N, then for sure N value. So that is a range of A which I will try, and that will take for sure O of N time. Now when this is fixed, so I'm just saying one thing, that now my A is fixed. That's great, my A is fixed. Now try to find any other variable which is C or a B, and then with the help of that variable range, I'll try to find the final range of other variable. What it means is that I know that it is fixed, so C, it will actually become nothing but N minus or let's say, we know, again we are finding the ranges of C. C is nothing but a range starting from 0, or let's copy this condition right here and paste it here. Meanwhile, do let me know what you guys are thinking. Rahul, I got 4 and 1 and 4 and rank 2736. That's great, Rahul, because like it's actually good if you get to know this question is hard, you won't be able to do it, so that you jumped on to question number 4 fast. That's the reason like you got a higher rank, and that's good. Now we know that okay, A is fixed, so what we can try off is that I know that one thing, that B plus C is equals to N minus A. Now that is a good condition, because I know one thing, that A is fixed, so I will have this value is with me. Again I have to find the range of C, so range of C is okay, that his condition is for sure true, it is more than 0, it is less than equal to L, as we saw for A also. From this we have to figure out some condition whatsoever. Let's see what we can have it. Now C will actually become as N minus A minus B. Now with this N minus A minus B, what you can just figure out, so like it can give you something, so like we just have to again figure out two conditions for our C, and also we'll have to figure out something then for B. Now for C, if it is n minus A minus B, now again it's just that we know it should be like this is the C. So one thing is like we can just simply place this C in these two places. That's one way, but we need to have more conditions for C. Now for that more conditions of C, what we could do is that, or let's say right now, let's say if we just place in that, okay, this is a C, so we know one thing for sure, that it should be more than equal to 0 and this should be less than equal to L. Now let's place in these conditions right here. So we'll just say that 0 is more than equal to n minus A minus B, and for sure n minus A minus B is less than equal to L. So we are trying to just find the condition for B. Can we find it or not? Let's see. Let's take this condition right here. We will just say that B is less than equals to n minus A, right? And we also know that B is less than equals to L, because that is for sure from this condition. And from this we can actually just figure out that your n minus A minus L is less than equals to B, and also we know one thing, that B is greater than equal to 0. So that is also true for us, that is also true for us. Now if these two conditions are true, so we can just say that, okay, and for sure everything is fixed in this, that this is fixed, and everything we have just removed. C we have removed, B we have removed. Now this condition finally remains that B should be greater than equals to maximum of 0 comma n minus k comma L. It should be less than equals to minimum of L comma n minus A, right? And I know my A is fixed. I know my A is fixed. It is just saying that, okay, you have a number B whose range is from 2 to 3, right? You just have to figure out how many number of such B's are there, right? That's it. How many number of such B's are there? Because for sure for this valid B, which means, let's say if I take, or let's say if my, let's say my range of B is from 2 to 5. Now I'm just saying for this particular fixed A, again mark my words, for this particular fixed A, if I take any of the B's, let's say B is 4, so for sure my C will be a fixed value. It will not be a range, it will be a fixed value. It will be a fixed value. So I know I will traverse on this range, which is O of n. I have found that this number B lies within this range. So for sure, how many, like what is the length of this range? Length of this range, for sure, B minus A plus n, B minus A plus, like R minus L plus 1, right? The range length always is R minus L plus 1. So I know the range length for this is 5 minus 2 plus 1, which is actually nothing but 5 minus 2 is 3 plus 1 4. So I have 4 values, which is 2, 3, 4 and 5. I have 4 values of B, which is giving me the range. Now when I know I have these 4 values, for sure for every corresponding value my C value will be fixed, just one value. If I take this 4, A is fixed. Now B I have make as one of the options. Now C will be just one value, because for sure A plus B plus C is actually summing up to n. It is not at least 10, at most 10, it is exactly equal to n. So for sure there's just one combination, one triplet which actually sum up to n, and that is the reason I can just simply say, I can just simply try for all the n's in O of n time. In the O of n time I have found the range of B. With the found range of B, I can just say that length range is actually R minus L plus 1, which is the range, which is this L and this is the R. I'll just say R minus L plus 1, and with this range length I'll just say, okay, these many number of combinations are there for this corresponding fixed A. So I just simply add this in my answer, range length, and I will keep on adding this range length for every of my A, and that is how you can simply solve it. So the main crux of this problem was that I will try on all the A's. Now if I try on all the A's, I have to find the range of B. If I found the range of B, that it will infer me that at any point in time, if I fix any of the B's, so for sure C will just be one value. So I don't have to look at C, because that will be nothing but just one value, which is this range multiplied by 1. That's it. That's the reason I don't have to look at the C part. That is the reason which makes it more more interesting. Bro, please do dry run, don't spam, bro. That's true. Like, what you want to dry run, get dry run. Like, give me that part. This was literally a PNC contest. That's true. Like, debugging diaries, what you want to get dry run, just let me know that, and please don't spam. Please don't spam. Cool. So that is the entire cause of the problem. What we will do is we'll just simply go and find for all of our A's, which we actually found out what is the range of our A's. Our age range is, where is that gone? That is above. Yeah, so I'll just try, as you know, my NL are fixed, so I'll try for all the range of n time. Now when this range is fixed, I will just go and find out what is the this value, which is actually L, this value which is actually R. I'll just go and find the length, like range length, which is R minus L plus 1, and I will simply keep on adding my answer for all of my A's. Cool. Let's quickly jump on the question statement itself, like, sorry, the the code itself. Meanwhile, if you guys liked it, then please smash that like button. That would be super helpful. It just says that initially my answer is this. My A minimum is, as I showed you also, my A minimum is 0, m minus 2 into L. As you saw, it will be let's cool 0, m minus 2 into L. It is A's value. A max value is minimum of n, L, as you saw here, minimum of n, L. Now when this A is fixed, let me just put it manually. Now I have to try for all of these A's, all of these A's, because now I'm saying, okay, my A is fixed. I'll try to find the B minimum and the B maximum, which is R and L, which I showed you in the code itself. Now this B minimum is, as you saw, 0, maximum of 0, m minus A minus L, m minus A minus L, and also the B max is L, m minus A, L, n minus A. Now with this, I know that this is a range of B, which is possible for this corresponding fixed A. This range length, which is B max minus B min plus 1, just a simple range length, will say that for sure the value of C will be fixed, just one value. Now just check, please just check that if this range is more than 0, then it's actually correct range length, which actually we are figuring out, and simply keep on adding your answer. Then with this, you can simply keep on adding your answer, and you will simply get the answer. That is for sure for this problem only possible when you have just 3 children, just 3 variables. If the variables would have been more, you could have done O of n square by this method. Just figure out the formula. But you could have done O of n square. So for sure, this problem, it can have a distribute candies among children 3 also, in which you might have 4 students, and you're bound to do it in O of n square time. Again, it can have a distribute candies among children 4 also, in which you have no limit at all. So in this way, you could have applied the method 1, which we discussed initially, but in the very beginning. Cool. Please try with inclusion. Yeah, for that will be the question number 2. That will be very vast and very specific for that. Cool. Now let's quickly jump on to question number 3. That would be super. See, like, we'll have a quick chat read, and then we'll go on to question number 3. Meanwhile, can you please smash, I don't know, like, for this contest every question is having more number of negative likes, but no worries on that part. Cool. But before that, can you please smash that like video? That was super helpful. Cool. Let's quickly have a chat read. भाई डिबगिंग डायरीज भाई कहाँ गया 2 महीने से, भाई लाइव स्ट्रीम हो चुकी है इतनी बड़ी देखा नहीं क्या? Can, but yeah, we are back. How can we progress for the third? That's no worries. For third, I'll go on to very deep on everything for it, like from DP to, like, from recursion to DP to not possible to increase time complexity to going to maths, going to PNC and stuff. We'll go on entirely for that problem. That's true. 3 by 4, third one we actually see very deep, no worries on that part. Like, for me, the third one was more easy than question number 2, so I know that third one would be much more, like, deeply. Gosh, this concept was totally based on commentaries. That's true, Shreyans. That's true. That's super true. Like, someone who made this contest was a super fan of maths, I guess. PNC contest, that's true. Try and just let me know. Aryan Sharma, I saw same in top ranker solution. Please try with inclusion exclusion principle. for the top ranker solution, like we'll have to, like we'll go and like look on to the inclusion exclusion for question number 2. Inclusion exclusion, that's weird. Question 2, like just let me know which question you were talking about, and then we'll actually go and look back. But let's meanwhile start off with question number 3. Before that, if you have not smashed it, just smash the like button. That was super helpful too. Cool, not tool. Cool. Just says that we are having an integer n and a string s is called good if it contains only lowercase English letters, characters, and it is possible to rearrange the characters of s such that the new string only contains LEET as a substring. Now, it says specifically that I have length n, integer length n, and for sure with like this question we're gonna solve with combinatorics itself, which means we're going to solve with, like as you were saying, inclusion exclusion, we're going to solve with that itself because it's the most intuitive way in that form of itself. So it just says that I have the n length. Now a string s is good if I can get any substring of lead, and just to get that I can rearrange any characters whatsoever. So the obvious condition becomes is that for sure in my string of length n I need to have a LEENT at any place, any form, jumbled, not jumbled, here, there, but it should be inside my string. Anyway, I can just bring it up, club it together, and can form a good string. That is all. I have to return a total number of good strings of length n. So my entire task is I have a string of length n, right? In this string of length n, I know that I want to make it a good substring, so I will actually place a L, I'll place a E, I'll place a E, I'll place a T, and again to just place it, it can have multiple number of places, but we'll go into it later on. But I'll place these many number of things on this, and then remaining thing I can place out anything. Now what comes in anything? Anything comes from A to Z, anything. Now the first obvious thing which comes to our mind is that okay, I have these n locations. I'll firstly choose 4 locations. On those 4 locations I'll try to permute these LEET, which is 4 factorial upon 2 factorial. Just simply, if you have 4 things, which is 1 2 2 4, right? If you want to permute them, so if it would have been 1 2 3 4, so permutation is 4 factorial. Just simply the number of ways you can just actually keep on placing that. If you can't, which means you just have to place it somehow. Oh, like okay, not it's not permute, but yeah, it's just options. I have 4 options and I can place these into 4 locations. So I can place up 4 here, 4 here, 4 here, 4 here, 1 here, 1 here, 1 here, 1 here, 2 2 2 2, 3 3 2, like any combination whatsoever. So that will be the number of ways I can have, which means for every location I have n ways, right? So that will be n into n into n into n for us. But let's say if I just ask you if I can just place a 4 here, which means to place I have like to place on the first location I have 4 values, which is 1 2 3 and 4. I placed a 4, so number of ways to place it's 4. If I place a 3, that's occupied, like for sure one number is occupied out of all these numbers. For this location I have 3 possible options, so answer is 3 multiplied by 3. For this location I have 2 options, multiply by 2, multiply by 1, so that's nothing but n factorial for us. But you saw that in this 2 numbers were same, so you have to say that you choose to those, you just try to arrange those, but that would not work. So just simply divide by same number of factorials, so that will be divided by x factorial. Let's say frequency is x, so that will be x factorials. So one way is okay, I just try to choose LEET, I just choose NC4. Now again I'm saying that might work, that might not work, we'll see if it works or not. NC4 into, we will say that we will just get these particular of them arranged for factorial to factorial. Now remaining places are n minus 4, so I know the remaining places are n minus 4. remaining places are n minus 4. On n minus 4 places, I can place out anything whatsoever. Again, I can place out anything whatsoever. If I place out anything whatsoever, I can place out anything as in from from A to Z, which is 26 options. For every location, I have 26 options, but for locations of n minus 4, which means 26 options for this, 26 for this, 26 for this, and so on and so forth. 26 raised to power n minus 4. But you know that you only have 26 characters. If the locations are n, for sure some character will repeat, which means you need to just do a division for those specific clubs, like groups, which are same. If let's say I placed a and A, so for sure I have 3 A's same, so I have to do a 3 factorial for sure. And if you're just confused on any of the factorial stuff, you're not like that much confident in PNC and stuff, just go and have a look at this particular doc. Like again, like PNC can have multiple such formulas. You don't have to remember any of the formulas, like for sure, but just simply look at the doc which is available. Like that's the reason I shared this doc for you guys. So you will see that there's a problem similar to basic formula. How many ways to permute the letter of the word happy? Now it just starts permuting this happy. Right now, to permute this letter, like word happy, just say, okay, I have these 5 letters with me. He considered that P1 and P2, like both the P's, he considered that as different. So with that, he just considered that P1 and P2 and P1, that would be 2 different combinations. But you saw that, okay, that would not be same, because for you it will be both P and P, not P1 and P2. So that would be nothing but 5 factorial, which is nothing but the HAPPY upon 2 factorial, which is nothing but the P's which are repeating. So you know that how you can just do a permutation of those numbers. So coming on back, that might not work because we don't know the X, which means the frequency of the other numbers, so that might not work. But yeah, what if I knew it, which means I just say, okay, my A has a frequency of, let's say, X1, B has a frequency of X2, so on and so forth. Let's say E has a frequency of X3, again X3 with including this, or maybe without including this, who knows, because I've included here itself. So let's say I don't include, which is actually frequency is X3, and also let's say the frequency comes in, which means if I would have included here itself, I would not include here. If I have not included here itself, I would include here. But anyways, I'm right now considering the entire complexity, the entire number of E frequencies. Okay, cool. Then can come, like, let's say L, then can come T, then can come Z. Let's say frequency is X, let's say it is X5, L is 12, T is 20, and Z is 26. So these are frequencies of these characters respectively. For sure, the final answer would look something like, you need to have, so one thing is that, okay, you just start choosing 26, sorry, like N, you just choose 4 places out. Okay, I choose NC4. Now for those NC4 locations, you have just placed your LEENT. Now when you have placed that, the remaining places which whatsoever you have, you will just say I have 26 characters for those remaining places. Remaining places are n-4. On those n-4 places, I can just place any of these characters, but the frequencies will be matter for us. So I'll just say x1's factorial into x2's factorial upon, like, I'll just simply keep on doing it until x26 factorial. Just saying that the frequencies need to be divided with the actual number. And for sure, if I just choose these 4 numbers, so I'll just know that to permute them, again I have 4 factorial upon 2 factorial ways, and for the remaining numbers I have these many number of ways. That would be it. But you know that these x1, x2 up to x26 are unknown, so you will have to try for all combinations of this. Again, for this fact, which means x1 plus x2 up till x26, it needs to sum to what? It needs to sum to a number which is actually n-4, right? This should actually make sure. So you will have to kind of try for all possible values of x1, x2, x3, which means, again, this can have n values, because for sure you will try from x1 0 to n, x2 0 to n, x3 0 to n, and then combination of all of them, n ways, n ways, n ways. So one ways you just go and try for 26 raised to the power n, oh sorry, yeah, sorry, n raised to 26. For this n ways, n raised to 26, yeah, that is your complexity, which if you will go and try for all the ways for x1, x2, x3, which is for sure not gonna work. So when things not works for us, as in like you were trying to do what? You were trying to place it right and making your answer good. You want to make your answer you want to make your substring good. That's the reason what you were doing. You were placing this on your input string. Right. Meanwhile, the folks have joined in, or any new folks have joined in, can you please smash this like that? Would be super helpful. Now, the thing which you were doing was you were actually placing your characters on these locations. I'm saying that placing characters, you will have to obey the possible combinations. What if you just try to say, okay, I will just not place the character here, which means I will just try to find the not ways. I can easily go and find the total number of ways to place A to Z characters in this entire string, which is nothing but 26 raised to the power n. At every location, I have n locations. At every location, I can place any character from A to Z, 26 ways, 26 ways, 26 ways, multiplying, getting 26 raised to the power n. I'll subtract what? I'll subtract the number of ways to not get good substring. Now, to not get a good string. Now, what can be, like, what was a good string? Your good string was LEET. So if your L will not occur, if your E will not occur, if your E will not occur, if your T will not occur, right? If your L, it doesn't occur, or if your E doesn't occur, or if your E2 doesn't occur, or if your T doesn't occur, then for sure it's a bad substring, right? That's for sure. Now E2 is saying E should be twice, E is saying E should be at least once, right? So these conditions, you know for sure, if L doesn't occur, or E doesn't occur, or E, like E2 doesn't occur, or T2 doesn't occur, that will be your bad substring. So what I will do is I'll just find this value itself. I'll find this L. Now L means L doesn't occur. L, like you can just imagine L, E2 and T dash. Now dash is saying it doesn't occur. L doesn't occur, E doesn't occur, E2 doesn't occur, T doesn't occur. Right now or T doesn't occur. Now to find this value, as you not sure if you know this or not. Now if I just ask you A, now or B is as equal as A union B, right? Now I'm just showing the Venn diagram. If I have a I have a B, I have a I have a B, I can write A union B as A plus B, but minus A intersection B, right? Which is A plus B minus A and B, right? That is the simple thing of A or B. So I can just simply imagine this OR as a union and the intersection as a AND, right? So please keep on doing it vice versa. Now this is how a inclusion exclusion principle works. I want to find the A or B. I use the simple A, B conditions here. Let's say if it was a triplet, which is this, this and this. So as to find a A, B, C, if I just ask you, I want to find a A union B union C, it will be nothing but A plus B plus C minus, now simply taking 2, which is A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. That will be your simple answer, right? That will be simple answer for 3. It is for 2. For your case, it is actually a 4. It is actually a 4. For your case, it was actually a 4. L, E, E2 or T. So what we will do is we'll actually find the answer for this one. How are we going to find it? Let's see. Simply just copy the same formula. Take ones, then minus, then take 2, then plus, then take 3, then minus, then take 4. Simply the same formula. What we will do is that we know that we have to find this value, which is we want to find L union E union E2 union E2 union T, right? We will find this. Simple. We will find and say, okay, it will be L plus E plus E2 plus T. Now comes the minus L, which is on the left, L intersection E, that's one thing, minus L intersection with next thing, which is E2, minus L intersection with T. That is, L is done and paired with next numbers, but E, the next E needs to be paired, so E intersection with E2, right? And then next thing is E intersection with T, and then next thing is like E is done and then E2 intersection with T, right? Again, I have 4 numbers, I have to choose 2, so 4C2 is 4 into 3 by 2, actually 6. So I have got 6, yeah, I've got 6, so that is done. So just please verify, because it might happen, you might miss something while writing manually down. Now comes the plus point, you just simply do a plus on this particular number. Now what could be that case? Simply you just simply say I will have L intersection E intersection E2, right? Or I can have a L intersection E intersection T, or I can have a, like you saw, it was L E E2, it is now L E T. It could have been L E2 T also, so it can have been L E2 and T, right? And for sure last could have been E E2 and T. Last could have been L E2, sorry, E E2 E E2 and T. That is for your 3 combinations, which is 4C3, actually 4, so you have 4 values. That's true. Now for last, I will have simply all of them as subtracted, which is L E E2 and T. Cool. So that portion is done. Now comes the interesting part, which is finding the values for corresponding these numbers, which is for sure you just said a L, which means L should not come. Bro, you are just saying L should, okay, let's change the color. I'm just saying L, again numbers are fixed, I have n places, I'm just saying that L should not come, because ultimately my answer would have been either L is not there, or E is not there, or E is not twice, or basically T is not there. So or simply converting that to your written knowledge, which is union. Cool. And for sure finding out this particular expression itself. Now why this is needed, we'll go on to it, but yeah, let's individually find what could have been the values for L dash. L dash is L did not occur. I have 26 numbers, L is not occurring, which means remaining numbers, which are 25, are occurring. So 25 numbers can occur on all the n locations, and it should happen. Except n, everything can occur on other n locations. So that will be nothing but 25 raised to power n. What if E is not occurring? No worries, bro. Again, E is just a number. If it's not occurring, same as L, it will not occur. What if E is not occurring twice? E is not occurring twice, which means that E can occur once. So I'll make sure E occur once, because if E will not occur anytime, then it will happen this also. So I might actually repeat some cases. So in this I will make sure E comes once, and that's only it, once. Here I make sure E will not come. Here I'll make sure E should come once. So what I'll do is, I'll firstly, out of all the n locations, I'll choose a location to place one E. I choose one location out of n. I choose one location. Now that one location is fixed. Remaining locations are n minus 1. For those n minus 1 locations, I can place remaining 25 alphabets, which is 25. So that's nothing but E2. Cool. For T, same as this, which is 25 raised to power n, right? Just quickly ignore that. If you have any doubts whatsoever so far, any chat reads, anything whatsoever, if you have, just comment down below. Patapat. We'll quickly move on. Like if you have anything whatsoever for inclusion, exclusion, or anything whatsoever, just comment down below. Fatafat. We actually go on, and yeah, if you have just watching, or if you have any ideas whatsoever, just comment down below. Fatafat. Then we actually start, or like if you have any doubts on what numbers calculated, what number are there, or anything whatsoever, just comment down below. Fatafat. Bolo 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 bolo. Bolo bhai. Bolo. नहीं है तो बताओ, अगर नहीं है तो बताओ, है तो बताओ, बोलो. Just write down below. Make sure that you have found these formulas and this formula. That's it. And this is the only thing. The entire problem is done. You know everything out. You know L, you know E, you know E2, you know T. Just place these values. L, I'll place the same value, 25 raised to power n. E, I'll place the same value, like 25 raised to power n. Just simply keep on placing it. 25 raised to power n plus 25 raised to power n plus 25 raised to power n plus 25 raised to power n. No bro, it is not 25 raised to power n. It is nc1 25 raised to power n minus 1. जल्दी बोलो कुछ दिक्कत हो तो. Bro, please suggest me. That we will do. Okay. And T for T 25 raised to power n. Okay. That is done for this values. Now L intersection E, which means for sure both L and E are occurring. Now again, L intersection E, both L and E, the condition should satisfy. L was, it should not occur. E was, it should not occur. Both L and E should not occur, which means I am saying right now both L and E should not occur. Again, it's a minus number. So, or you can just do it, it's a plus number, just do a minus number. So I'll just keep it in a bracket itself. So I have computed this value right now, this value right now. Now I'm computing this value right now, this value right now. Keeping it in minus. L is not there, E is not there. L and E both are just one, right? So I'll just take, okay, both of them are not there. Remaining number are 24, right? Locations are n. Cool. Again, L is not there, E2 is not there. Cool. So again, that's a simple plus. L is not there, E2 is not there. E2 is, one E is for sure there. I'll choose a location, I'll place a E firstly, then remaining numbers are 24. Remaining characters are 24, N and E, but the remaining places, locations are also n minus 1. If I just place a ln, like not E, L and T are not there, same as L and T, which is plus 24 raised to power n. And then I'll just say E and E2. Okay, like E is not, like it is saying that E is not located. E2 is saying E is located once but not twice. Both are contradictory. It is saying E is not located. It is saying E is once but not twice. Oh, that's not possible to have it. So the intersection is 0. Cool. Now for E intersection T, again same as L and T, L and E, 24 raised to power n, no worries. And then last is E2 intersection T, same as E2 intersection L, which is nc1 24 raised to power n minus 1. Just quickly write down below if you have any doubts. Now comes the third part, where I just take intersection of these three in public, right? Just taking a plus sign and just grouping that up right here, saying L, E and E, L, E and E2, that's gonna be 0, right? Again, this is also gonna be 0, this is also gonna be 0. Only thing remaining is this. Now why why 0? You actually know that part. L, E and T for sure. L should not be there, E should not be there, T should not be there. Remaining letters are 23. Locations are n. Cool. L should not be there, E should not be twice, which means it should be there. Okay, I'll just place 1. Remaining letters are 23, but locations are also n minus 1. That's good. So that will be our final solution. Cool. Now simply modify this to a smaller values. 25. So what I can do is, I just know that it is 25, so I can just know one thing, it is n plus 25. It is m minus 1, so I'll just simply do a n minus 1 outside. It is n, this value, plus these three values, which is 3 into 25. M minus 1 has gone, so it is 3 into 25. Now minus this new value, 24 raised to n minus 1, keep it out. 24 one time, n and n, 2 into n, take it 2 into n, plus 24 once, twice and thrice, 3 into 24, right? And then lastly this number, which is plus 23 raised to the power n minus 2, simply n plus 23. That will be our answer. So this was the value which we calculated for A union B union C. If you forgot, it was A union B union C. Where was it gone? 26. Okay, it's gone somewhere, I don't know why. Oh yeah, so we want to find the value of 26 like ratio of n minus this value, which was A, like this not present, like this, like L should not be there, or E should not be there, or E is not twice, or T is not there, right? So this was 26 like raised power n minus this value. So I'll just simply go and say that my value is 26. My value is, I'll just change the color. My value is 26 raised to power n minus this entire value, which is right here. So simply change the sign. It will be minus, it will be plus, it will be minus, right? So it will become a 26 raised to power n minus n plus 75 into 25 raised to power n minus 1 plus 2n plus 272 24 into 24 raised to power n minus 1 minus n plus 23 into 23 raised to power n minus 2. And that is, just simply make sure do a modulo while doing anything, which is this you cannot find if you don't know binary exponentiation, which is nothing but just doing and finding modulo. If you don't know, just a quick recap of how binary exponentiation works. It is A raised to power b mod m. It just says that while you have some b, just go and find if your b is odd, which means if your b is odd, which means you should actually multiply your answer by a, which is you will initialize your answer by a, which is int answer, multiply by 1. It is not int, it is actually keeping on b modulo. So answer will become current answer into the current value of a, and or short doing a mod. Else if the b is even, then instead of multiplying answer by a, simply multiply a by a itself, and that is by mod. And then ultimately you can simply like return the answer. That is simply how you can find, or you can just have this function of modulo, saying modulo a, b and m, saying I am doing a modulo of a raised to the power b mod m, and it is the most efficient solution for this modulo. Cool. When this is done, simply go and find and just simply compute these values, and that's pretty much it for this question. Cool. Thank you so much. Can we please smash that like baby? That would be super helpful. Just 3 more 40 likes, that would be super great. Then let's quickly jump on to the code itself. It's pretty easy. Firstly, as I showed you, the same code for modulo exponentiation. You just have the answer. I just take everything in LL, no matter if it is long or not. Like usually answer will be int because I have to do modulo with 9 plus 7, but still I take in LL because there can be chance of overflow anyways, some bit values or something like that. So take in LL. Now I have my answer. While b is more than 0, simply if it is an odd value of b, simply multiply that my a by answer, and then for sure if you have reduce one value of b. If it's an even value of b, just simply multiply your a by itself and also reduce by your b by half. It's a simple binary exponentiation called as fast modulo exponentiation, and that's pretty much useful for us to actually compute the number a raised to the power b mod m. When this is done, simply as I showed you, I just computed these values, which is first value, which is 26 raised to the power n, 26 raised to the power n. Let's see this value, first value, right? Next is n plus 75 into 25 raised to the power n minus 1, which is this value, next value, minus, right? I'll do minus right here. Then the next value is 2 into n plus 72, 2 into n plus 72, 24 h power n minus 1, which is the third value. And then finally the last value, which is n plus 23 h power n minus 1, which is this value right here, 23 h power n minus 1. It should happen. It was this, so it should be n minus 1. So this should be n minus 1, right? A bit mistake, no worries. Now, why I wrote here, why I did not write here, I actually wrote it in that line itself, but like in one line itself, but because of this thing, it was getting overflowed because it was not computing the entire modulo itself. So it was having bit issues. I tried writing in one line, but it was failing. I just wrote it in 4 lines, just individually modulo. I thought it's a long, so even if the values are both integer limits, so multiplying that, it should still remain in long limit, but it was giving overflow, so I have to bifurcate them individually and then lastly do a v1 minus v2 plus v3 minus v4, and then 2 mod is just that because of 2 negative signs which can be in the integer range, right? That's the reason. With this you can simply return the values. That's pretty much it. Thank you. Let's quickly jump on to question number 4. It's also pretty, it's the easiest one out of all the questions, but if you have liked it, can we please smash that like? That is super helpful. We're going to jump on to question number 4. Meanwhile, let's quickly have a chat read. That will be super helpful. Got it. Please try with the inclusion exclusion. That's done. I solved 2 but not 3rd. No worries, Shreyas. I'm going to suggest some more problems like question number 2. For question number 2, some more problems. Frankly speaking, this was a type of questions I have also seen for the kind of, like, not exactly a type of questions, but I've seen these mathematical range kind of questions that you have to modify the range, that it comes in this particular range XYZ, but something like this I have also not seen previously, so I cannot suggest any such. Like on Leetcode itself, I have never seen this. On Code Forces I have seen this kind of questions, but on Leetcode I don't think so, because it's kind of strange to have this question. It's actually good also and bad also. So yeah, on Leetcode I have not seen it, but yeah, on Code Forces problem BC is kind of like this hacky but yeah, maths, it's kind of useful for that also. Can you suggest a move that shorten your face circle? It's covering the board. Oh, sorry, I did not look at it. Is it still, which portion I did not? Okay, so that was your, okay, got it. That was a face circle which was covering that portion of the board. Okay, I'll just quickly show you that every portion, if something was invisible. So let's quickly see. So this was the piece of code which was of binary exponentiation. This was a piece of code for the final answer which we got, and this is the backtracking which we were doing previously and computing the final answer in this way and doing the inclusion exclusion of 4 variables, which is L bar, E bar, E2 bar and T bar. Cool. Let's quickly jump on to question number 4 now. Right. But yeah, if you have any other doubts, then just be let me know. Hi, I just solved 4th question on my own. That's great, Abhishek. I was afraid that I won't be able to touch 4th question. So in this contest, something was that question 4 was easy. Question 2 was, God knows, hard. But question 3 was also kind of mediocre hard. So yeah. Question 4 was comparatively easier than question 2, question 3, but yeah, it's still like question 3 is actually standard problem. If we have seen previously, we can do it, but 3 and 4 was a bit tricky for us. But now, as I have tried, I succeeded in solving. That's what it is. Oh. यार इतना बड़ा मच्छर. Gross. Chi. Ja bhai. It was so big. That's what she said. Cool. I was afraid, but now I have tried. I succeeded solving it. The BNC documentation you showed a standard technique named Beggar's method. That's true. That's true. I forgot the name. Beggar's method. Yeah. We have studied it in our 12th class, but in 4 years I did not study it. But yeah, it's called as Beggar's method. It's also called as one more name. Wait, I have that in my notes itself. If I just go and check in my notes, it's also called as by one name also. Beggar's method, and also one more name. I forgot the name. Mathematics, Bernoulli. That was called as stars and bars. Nahi. There was one other name, stars and bars. Yep, it's also called as stars and bars. So what you can do is, wait, I'll show you one more documentation. Let me go and search that on Codeforces. No, okay. Codeforces, permutation and combination. Cool. Study combination study notes. So like Codeforces like has a great guide of PNC problems, and also I don't know if stars and bars are here. Stars and bars are not here. So like that thing is also called stars and bars, I guess, right? That's what she said. कोई idea है क्या? एक minute, I'll just go back to your comment. Just a quick thing, just checking out that, because it's also a very, yeah, see, it's entirely covered in this stuff itself. Just like every math algorithm which you wanna see, they have covered it in this. So that's also good. You can just check it out. That's kind of a great page to look for, right? I'll just have this also commented. Now going on back to the actual problem itself. So like I also tried to have my documentations open so you can see my documentations about PNC, because again it's math, it's not that great. So I'm just figuring out all the formulas and stuff, everything out. Cool. Now coming on back to the problem number 4. Let's quickly jump on to question number 4 itself. Meanwhile, if the folks are watching in, can you please smash the like button? Super helpful. Happy Diwali, bhaiya. Happy Diwali, Supreet. Yeah, if the folks don't know that today is Happy Diwali. Today is Diwali. So yeah, Happy Diwali. The page documentation is on that group. Please suggest me some problems on similar patterns to question number 3. Question number 3, you can find many. Just write PNC problems. Leetcode. You can simply find many problems. Let's see. PNC problems, Leetcode. So there can be like many questions you can find like for this. So it's just a PNC based principle. So this is not PNC but backtracking. It's a permutation questions. There is this question, not sure, it's actually not entirely backtracking. Yeah, it's also not. Yeah, it's this one is math one. That seems like a math one, but yeah, it's also kind of solvable by simple array. That is not good. Math problems, solutions, doubles. But again, yeah, this is one of the questions. Oh, this is the same question which we saw earlier also. But no worries, like I'll collect the questions for math specific, and like if you want to still want to find out, just go and watch the maths playlist. If I will tell you, Control-Shift-N, YouTube. Now in this, if we just search of maths intuition building playlist by Aryan Mittal. So like you can just see this playlist of maths which we can have. Where is this gone? Credit playlist, DSA. There should be mathematics. Yeah, mathematics and number theory playlist. So in which you will find the problems for maths and number theories. that would be pretty much good for covering the maths and number theory concepts, and that's pretty wide, like pretty worst for us. Don't see the ad. Let's go. Cool. Let's quickly jump to question number 4th. Yeah, let's have it. Maximum spending after buying items. So that's gonna be pretty easy. So you'll see that you are having a n cross n integer matrix with having the values. Now it just says that for the jth item in the ith shop, so I have these shops S1, S2, sorry, S0, S1, S2, Si, and S of m, or you can say S of m minus 1. And then for every shop I have the items with them. Now these are the jth item. For us, right? Now the jth item has a value of values of I comma j. Now it just says that the values are decreasing in order. So for sure the last value will be the minimum value for that particular shop, right? So it is the same thing. And also we are saying that on each day I would like to buy a single item. On each day I like to buy a single item from one of the shops. Especially on the dth day, you can pick any shop. I can just choose to pick any of these shops. In any of these shops I can choose to buy the rightmost available item for that shop. I'll go in the extreme right, which is having the for sure minimum value for that particular shop, jth shop. I'll just choose to pick that value from that particular shop. I can choose any of these shops. If I choose it, then I just have to pick this extreme right value. If I pick it, then it will be gone, right? Cool. Now I have to find, and for sure at the day d from 1 to 3, at every day my value will be increased by values into d. Now when this is done, I return the maximum amount of money that you can spend on buying these numbers. I have to spend maximum amount of money. So ultimately I just want that this values, if I just do a summation of these values, it should be maximum. Summation, if I want to be maximum, for sure individual numbers also needs to be maximum. If this individual number needs to be maximum, which is the multiplication of values into d, if this number needs to be maximum, so for sure individual number, which is d, needs to be maximum and values needs to be maximum. So what I will do is I will go and try to start my procedure in such a way that ultimately I am clubbing maximum value with the maximum d. So ultimately, let's say this is the maximum value, this. So I will just make sure I am starting in such a way. And now if I want that, okay, maximum value should be clubbed to maximum d, so for sure the opposite is also true. Minimum value should be clubbed to minimum d. So I know that I can start from these endpoints. So I'll just keep track, okay, whosoever is minimum in this, minimum is, let's say this one, minimum, let's say it is 1, it is 2, it is 3, it is 4, it is 5. I know minimum is this one, so take this one and multiply with your d. Again, next offerings you can have is this one, this one, this one, this one, this one. So you saw, out of these m options you have to take one option. Out of these m options you have to take one option. Now if you want to take this one option, simply you will have to keep those m of these end values inside your priority queue. Whenever you take the value from out of the priority queue, simply whatsoever is the next element, just push it back in your priority queue. You can take a set also, you can take a map also, you can take a priority queue also. Just matter of fact is you have to grab out the minimum element whatsoever you want. And with that, what you will do is, okay, let's quickly jump to the example statement itself. I have a shop having a value 8, 5 and 2, other shop having value 6, 4 and 1, other shop having value 9, 7 and 3. I know I have to grab from the very end, and I know that I will take the minimum value. So I'll just take this 1 into 1, right? D, it is d is 1. I want the sum, d is 1. Cool. Next and for sure in my priority queue I have now these 3 as the options which I can take. Again I'll take this 2. Okay, now these 3 as option, 2 into 2. I'll take this 3. Now this is option, 3 into 3. I'll take this 4. Then this is option, 4 into 4. I'll take this 5. This is option, 5 into 5. I'll take this 6. Now this is option. 6 into 6. Now this is empty. So you don't push anything out. I'll take this 7. 7 into 7. I'll take this 8. 8 into 8. Ultimately, I take this 9, which is 9 into 9. And that's actually my answer. So you saw that I tried. Ultimately in the end, my largest value should be clubbed with the largest value of t, which will give me the large value. And ultimately I just want to compute all the values which are as large as possible, giving me the final value which is as large as possible. That is the ultimate thing which we have to do for this problem. Just simply keeping track of all the end elements inside a priority queue, and for sure just keep track. Okay, I'll keep track with the values. I'll keep track as I and a j. You can make it a bit smaller rather than using a vector inside a priority queue. You can keep a track of a vector, like you can keep track of a pair also, which is value, and a combination of ij. Ij combination you can just infer directly as I into m plus j. So you can just store your ij pair in just one value, which is I into m plus j, and then while computing you can just return back. Let's say this value is v, so you can return back your I as v by m and j as v mod m. So you can just figure out back this value. So it's just a bit compression and decompression technique used inside the matrix. Although the constraints are not that big for this problem, if I just have the constraints, okay, the constraints, if I just go back and show you, it's not that big. It's just 1e4 or 1e5, I guess. Yeah, it's just 1e5 entirely. So it would not much hamper us if we use a vector as an entire thing, which means value I and j. If the constraints would have been, let's say, this values would have been, let's say, 1e5, which means my total constraints, which is this entire thing, it, let's say, combined would have been 1e6, 1e7. So probably I would have used a pair itself, saying, okay, value, and then I and j combination by saying I into m plus j. I into n plus j. For this, n is number of columns. For me, usually I keep, if you will go and see, I'll keep track as n as number of rows and m as number of columns, but in the question you will see, so that's the reason I show you I into m. M is number of columns plus j. That's the reason. Cool. Let's quickly see the code. It's again pretty easy. That is nothing. I did not use it. I just wrote it. So I just found out my n and m. I just use a priority queue, which is actually min heap, keeping track of a vector. Again, how to represent the min heap is just saying vector, and then again a vector of vector, and then a greater of vector. You just push back all the end elements of every row. I go on to every row. I just pushed on all the end elements in my priority queue, and then ultimately I started my answer. D is 1 initially. Ultimately my priority queue is empty. Just keep finding the last element or the top element of the priority queue. Whatsoever is having the minimum value, just pick it out. Add that in your answer, which is answer plus this value, which is this value, which I got from priority queue, into D, which is the current day which I have. Increase the day for the next number. You get your I and j. Check if I have a previous j. If yes, if I have a previous j, just simply push that previous j inside your priority queue itself by saying, okay, it's a previous j value, it's a I, and it's a previous j. And simply keep on doing it until you get the answer, and ultimately you will just simply get the answer. Cool. So with this, you can just simply get this solved. Let's quickly go on to the chats, then we actually end the stream, because tomorrow morning we have to wake up early. Lately I have been not able to sleep early, so it's hard to wake up early. That's the reason the daily questions are coming late, and it hurts when after doing so much mehnat, still it is not able to reach to you guys. So I'll just wake up super early from tomorrow onwards, and because lately I have been waking up around 9ish, 10ish, because I sleep around 4ish, so it just becomes very hard to wake up at 5:30 or 6. But yeah, we'll actually have efforts. But yeah, if you guys have not checked the Instagram out, that would be great if you just go and check it out. We're actually starting to post many stuff on this, we'll have for sure it's written easy peasy DSA. You will see ton of content coming on this page. So if you're gonna if you wanna have it watch, it will be funny. but it will be funny, but with a twist. Like right now, just like the content which I put in, like it's like right now it's just funny, but I have entirely planned out many stuff. If I just go and look, yeah, that's like entirely planned out many stuff which is actually gonna be funny, but you will be learning a lot in that. So like my entire theme will be fun, but then a learn. So that's how I'm gonna like project everything out. It's easy peasy DSA. I don't know why I put this name, easy peasy DSA, but yeah, that's gonna be it. Cool. We will quickly have a chat read and then we quickly end this stream. Is CP necessary for internship or DSA is enough? See, अगर CP करी और अगर प्रोग्रेसिव इंप्रूवमेंट नहीं हुई तो तुम CP करते रह जाओगे और कुछ नहीं होगा उससे. I'll tell you my story. मैंने CP करी, CP करता रह गया. Later, when my internship came, I realized that the question asked by companies are not what I have done in my CP journey. I did not reach expert or like expert, like I reached expert, but not at that like near purple. I did not reach that point. And even so, if you don't reach that point, so you would have not gotten into the genre of doing more graph questions, more DP questions, because problem A, B, and C are more of just straight up ad hoc questions and stuff. So if you are still struggling in that range of newbie, pupil, and like that one more I forgot, before, after pupil and before expert, that's fuck, I forgot, but yeah, like that light green color. If you are in that range and if you have not started doing Leetcode, you are just like, it's a mistake which I did, which I don't want you to do, because what you will know na ki you have an idea to solve the problem which you will think, okay, I do code processes which means I am like greater than the ones who do Leetcode, but you might have not seen a problem which is actually asked in an interview. For sure, until like still, like let's say if you have been like a purple, like if you have been a candidate master, still there can be a chance. If you don't do Leetcode, still you might fail in an interview. Why is that the case? Because in an interview, the point is that you are good in programming or stuff. You should have seen similar kind of question before. It's a 45-minute interview in which 5 minutes are just for introduction, 5 minutes for question, remaining is 35 minutes. Even if you will try for everything out, you will have your starting at least 5-10 minutes to discuss, because the interviewer might just give you a question itself. If he give you a question, then for sure you will ask him clarification questions. 5 minutes to give him a question, like roughly 1-2 minutes clarification question, roughly 4-5 minutes coming on to a solution. At least he should actually know that you have not known the problem, you came up to a solution. Then again 4-5 minutes to code it, remaining 50 minutes for a hard follow-up. So that is not okay, which means even if anyway you took more than 5-10 minutes in thinking for answer itself, you will fail the interview. That is the reason knowing a problem or knowing a similar problem before an interview is very important, and that is what a luck people tell. Why is luck a factor? Because it's a factor because knowing a problem previously gives you upper edge from a person who has never seen that problem, because interview time is constrained for both of you. You have seen it, he has not. That's the reason. So I highly recommend, if you're doing CP, good, do parallelly, but please make sure to do Leetcode. It is a mistake which I did for the first year, second year, third year. I did entirely CP, and that is the first mistake I did. I should have done Leetcode parallelly, but I used to think, okay, Leetcode is bakwas, bacche karte hain Leetcode to. That was the like biggest mistake which I realized after my internship. Fortunately, I got in, but after I realized, okay, that's the biggest mistake, because I looked for other interview rounds for other companies in my college when people were giving the other rounds for other companies, because like our company was the first one to come in a college. So like we just used to ask for other folks, like what's your like question asked. Everyone was getting questions which are actually standard from Leetcode, but I was like, oh, I'll solve it. I was taking 15 minutes, 16 minutes just to solve this question. But if I would have already known it, that would have been much beneficial. So that's pretty much it. The conclusion is Leetcode enough. Yep. For interviews, Leetcode is enough. Period. Cool. BGV सब कंप्लीट हो गया है भाई ब्रो. HCL टेक ज्वाइनिंग कब देगा 23 बैच को कोई आइडिया है क्या आपको? Not sure. You can just confirm from any one of the folks which are actually inside that company. That will be super helpful. They can actually tell you, like let you know what's there and what's not. I don't know why this is like this is the yellow, this is the yellow. It seems a bit weird, but yeah. Cool. One, like, we'll quickly wrap it up. We'll actually have these questions tomorrow in the live stream, so like no worries, just come up tomorrow, like for sure. Can you please smash it, like just two more, that'll be super helpful. We'll quickly wrap it up and we'll have it into tomorrow's live stream, which is tomorrow for sure, 11 a.m. Last question please. Okay, there are many questions above. What's that for here? I solved two problems with DP plus prefix sums. Great. Second problem with DP plus prefix sums. That is great, but Prandi, DP plus prefix sums, was it solvable? As in, was the complexity good? If yes, then great. Because I also thought of it, but prefix sum was also internally, like I had to keep track of prefix sum also, but internally it was also computing the values again and again. Total contest was today's maths. Yeah, that's true. I meant inclusion exclusion based problems, so never mind. I find it on my own. Thank you so much. I understood your explanation. It is very clear. Thank you so much. ये मेरा second contest था. By the way, in contest क्या फायदा होता है? By the way, in contest का क्या फायदा होता है? Speed and pressure handling. Like you, let's say if you have a friend, so you both can compete, or at least you can just like disclose. Okay, this is my rating. Who's gonna compete with me? You both can compete, or then like just come out and show in public that this is my rating. I want to increase it. Like who tell me like who has more rating than me? We actually compete. So great to see you back. Thank you so much, Sarthak. Krishna, no. Okay, Aryan bro, मैंने contest के लिए register किया था पर attend नहीं किया पाया तो मेरी rating कम होगा या नहीं? Didn't make a single submissions. I think no. No. So that's good. No bro, rating will not affect if you didn't give contest. Thank you so much, Sarthak. Last question please. Topics like segmentaries, fragmentaries, tries, I have skipped them completely. Are they topic important from interview perspective or getting important? Fenwick trees, segmentaries, see again, that's entirely dependent upon the trend going on for the companies. Right now, I have many friends giving interviews in many companies. So there's a trend of question being asked of tries a lot, not of Fenwick trees or segment trees. I don't think that segment trees in general will ever be asked in an interview for the problem which cannot be solved by either your Fenwick trees or your, what was that called? Range sum? No, I forgot the name. Sparse table. Yeah, either it can be solved by sparse table or it can be solved by using Fenwick trees. Segment trees, they will not ask. If they are asking, they want you to fail. Like for sure, any problem give me of an interview, I can solve it via Fenwick trees or any other data structure. Internally, segment tree is not used. I'll highly recommend, if you are preparing for interviews, prepare tries. It is important AF. Prepare Fenwick trees, not that important, but tries is important. Please don't skip tries. And see, if you just simply want to get tries, just simply go and write. There are 3 videos for tries, and that's more than sufficient to just learn tries. As I showed previously also, Control Shift and just simply go and search try by Aryan Mittal. You will simply get a playlist. It has 3-4 videos. Just watch that. That's more than sufficient. It has tries from very basic, and that's more than important. That's more than sufficient. Sir, ID में Patel 98 में थे क्या? That's true, Farhan. Exactly, like memories. Patel 98. If the folks don't know, we have hostel, Patel, Malviya, and so on and so forth. So in that, the room number was G98. भाई का नंबर था भाई, मजा आ गया था उस रूम में तो. Cool. Segment 3 पर प्लेलिस्ट बनाओ प्लीज. I might, but I don't think it's important from the interview perspective. So if it's not, then I might not jump onto it. So yeah, it's CP and essay that I've told. What is the difference between CP and Leetcode contest? The type of questions. See, as I told you, you will never encounter a question which is actually same as that of CP, which is Corfusus. Why? Because people, which is the people working inside the companies, they take your interview. Now, these people are usually, they have entered the company itself by doing Leetcode itself. So they will ask what they know. They know what they will ask, what they know, right? Bhai, Kranjit, don't spam bhai. लिंक दो इंस्टाग्राम भैया जी, डिस्क्रिप्शन का लिंक काम नहीं कर रहा. ओ या आई हैव एक्चुअली लाइक मतलब that I have to change because this link, like it was an old ID, and for the folks who don't know, now like I have just, like, it's very hard for me to actually go, like what I'm planning to do is I'm planning to do live streams on this particular Insta ID and stuff, like as soon as we reach a bit threshold, let's say 500 or like around that 500, we'll have live streams and stuff. We'll also have live streams specific to you guys. बकचोदी करेंगे वहाँ पे थोड़ा, like, right? So that is what we have planned to do. But yeah, we'll actually have it done. I'll also have to modify that thing default one, so I'll do that later on. But yeah, thank you so much for telling. Krishna, happy Diwali. Aryan bhai, happy Diwali, Krishna. Is Flutter domain good for development in long term for my career whenever I switch to another company? See, development, it's never good or bad. Flutter is very small. You can just get it done very fast. Don't stick to one thing unless you think there's a huge projection forward, which is Python. You have, if you're doing something with Python itself, you can do it. Again, in Flutter, you can just integrate that also. So don't stick to just one thing. Okay, like Flutter is very small part of your entire workspace journey. You want to go and do and try many things out. And as a company, I would not hire you unless I am startup. I would not hire you as a Flutter developer. Like basically, in the beginning, you will actually be hired as a software engineer, which should work on anything whatsoever he is given. So you should be able to get up with one thing. So for sure, just make sure that that you actually just get everything done. Don't stick specific to one thing. If you want to stick it, just do it for fun. Like, okay, 40% of time Flutter, remaining 60 other things. Cool. Just please don't spam, yaar. Please don't spam, right? Nowadays, bro, miss the stream. Thank you so much. Anime Stan. Good night, bhaiya ji. Thank you so much. Good night. Bye bye. What is the scene of off-campus placements nowadays? It's pretty tough. Not that. Just keep on grinding. You will actually get it. But yeah, it's hard. It's pretty tough right now. Like I have seen, actually, it's pretty tough right now. Follow kar diya. Thank you so much, Ankit Raj. Can a fresher get an off-campus job? That's true. By fresher gets off-campus job for sure, and like London, like India, for sure there are many opportunities. But it's just that you have to try many times, and in all the companies whatsoever you see. Just don't say, okay, I'll go into this. No, try for every company. Cool. We'll just quickly wrap it up because it's actually 12:40. I have to actually go to sleep. I have to wake up early tomorrow. First and second में सिर्फ math था. That's true. Coding तो थी ही नहीं. Yeah, for question number 3 also, it's entirely maths. There is like roughly no coding at all. Just a simple binary exponentiation, which is very basic. It's just entirely maths. Reaching to a formula is more basic, for like more important in question number 3. So yeah, it's also maths. Follow, thank you so much. But yeah, for intense knowledge and replying to all the comments, thank you so much. Rahul, Ishan, second वाला में constraints वाला था coding का part. That's true. भाई मैं Leetcode Python में करता हूँ instead of C++, will it affect my interviews? Not at all. Not at all. You can have it in Python, you can have it in Java, you can have it in C++, anything whatsoever. It's just that the interviewer, actually there are some C++ specific companies, so you might not able to interview in that. But yeah, the same way goes for some Python specific companies, which a person who is developing in C++ might not interview in that. So yeah, that's actually absolutely okay to do in Python. Not placed this season, what to do now, please help. see, not with the season. See, this season has not ended. I am considering that you are the person who actually graduate in the next year, May or like June-ish. Again, you have 4 months. For our company itself, we are actually having hirings, like actually flagship hirings next month in December. So apply in Goldman. Apply in Goldman for sure. It's going to be a huge bump in hiring for sure. Any of you who of you are watching, just apply in Goldman if you are actually eligible to apply, because they're actually hiring, like, because they want more people. So do make sure that you actually apply, and just make sure that apply in as many companies as possible, Ankit, specifically for you. And please don't lose hope. You have these 6 months, just grind it out and get the results. Time has still not gone. And for sure, if the time, let's say if the graduation completes, still if you have completed, like still if you have not got the job, no worries. But keep on grinding. Don't fake it from yourself. I have seen people faking from yourself, just opening Leetcode, watching the screen, thinking of something else, playing video on YouTube, thinking of something else. Don't do that. Strictly studying, having a fun, थोड़ा बड़ा चलेगा, but not entirely. हाँ भैया हम तो बैठ के मूवी देख रहे हैं पूरे दिन, ये मत करना बस. Does company look for years gap in the placement? I mean, I am a double dropper in JE, so will it affect placement after college? Like, see, firstly, year gap is never looked at until unless you have an, like, if you have a proper explanation for it. Why you did a year gap. And for sure, anything before graduation never counted as an year gap. See, they might ask you when you will enter something like that now. So don't even enter anything from your like school experience in your resume. Start from your graduation itself. Just simple. So these folks will never ask you how many questions you solve on Leetcode and Code Forces. I just recommend give contest, and if you are able to solve 1, 2, up solve 3. If you are able to solve 1, 2, 3, up solve 4. This is how you should actually solve it. Cool. Mr. Ravi, if you have a good answer, then not at all. राहुल गांधी को वोट मत देना. Cool. Thank you, Modi ji. आजकल काफी गान चल रहे हैं आपके, but cool. Thank you so much for watching. Let's end this stream right here. Thank you so much for coming in, for turning in. It has been 12:45, but cool. Thank you so much for watching. You guys know, goodbye, take care, bye bye. And also please do like before going, that would be super helpful. Thank you so much for turning in. That's a new Instagram page. Do like follow, like whatever you want to do, because for sure a great comedy plus learning content is going to be coming in. Again, I'm saying learning content is a part, because I have strategized things in a way that for sure few things will be comedy itself, entirely comedy, few things will be entirely learning, but the major crux will be comedy with the learning. So that's going to be happening in this, because the time duration is 1.5 minutes, not on shorts. But yeah, we actually have it done in both shorts and this. But yeah, that's going to be my prime focus now, Instagram. So that's the reason I'm just stressing out a bit. Cool. Thank you so much for watching. Bye-bye, Tata, goodbye. Thank you so much for turning back in. Thank you यार, कितना अच्छा लगता है बात करके यार, बहुत अच्छा लगता है. Thank you. Bye-bye. तुम लोग मेरी जान हो, जान. चलो, cool, रखते हैं. Bye-bye. Bye-bye. Ending the stream right here. Thank you so much for watching. चलो यार, end करते हैं.